Let's understand environments and neural networks in the context of AI apps or AI applications. So environments is the area or the domain in which the agents work and they reside. Okay, the artificial environments are confined by keyboard inputs, computer file system, and character outputs. It could be anything. Okay, some software agents reside in unrestricted and unlimited domains. For example, one of the most famous artificial environment is Turing test environment. What is a Turing test? Well, the Turing test is very simple. For an uninitiated observer, if uh, a system is able to fool, uh, to make him believe that the responses that the observer is getting is from a human, that is a Turing test. So if a system is able to behave like a human for an uninitiated observer, the system has cleared the Turing test. Okay. Now there are multiple kind of environments in which AI apps exist or AI agents exist. So they are complete versus incomplete. A complete AI environment is an environment which has enough information to solve one entire branch of the problem. So typically AI problems are divided into branches, and the best branch, because you can, uh, so typically an AI problem is divided into smaller problems, and each of these problems are then further solved. So as you can imagine, this can go on and on to no end, and can lead to massive consumption of computing, and there's a good chance that the computer can just blow up instead of solving the problem. To to solve that problem to some degree, um, a branch and bound approach is taken in AI, which is you divide the problem into smaller problems and then start solving them one branch at a time. And whatever is the solution of the best, whatever is the best solution or the best branch that have been discovered, the newer branches are compared with the best solution. And if they are not performing as well, or if they're not giving better results than the best branch, then they are abandoned midway. So chess is a very good example that all the moves, all the scenarios are completely available, and that's why environment has complete information or enough information to solve one entire branch of the problem, how exactly one particular move is going to play out. An incomplete AI environment is exactly the opposite. It doesn't have enough information to anticipate solutions in advance. Okay. And that's why the goal in these environments is to find a good balance at any given time. That the agent is trying to optimize the situation again and again. So poker is a very good example. That's why chess was one of the first games in which AI was able to beat human, but poker is turning out to be much more complicated, much more difficult. What's a fully observable versus partially observable environment? A fully observable environment has access to all necessary information to complete a particular task. You want to recognize a certain image, all the data is already available in that image itself, so you can easily recognize what's happening. While partially observable environment deals with partial information to solve problems, right? So self-driving cars, for example, is a prime example. It doesn't have all the information, it has to continuously work with partial information. Then comes competitive versus collaborative environment, which is competitive environment is the scenario in which AI agents are challenged by each other in the same environment in order to optimize the outcome. For example, Go and chess, these games will compete with AI agents on both the sides, and they both will compete with each other to come up with the best outcomes, right? And a collaborative environment is a scenario in which the agents will work together. So self-driving car has the best is one of the best examples. Multiple sensors work together to avoid collision. Right. Then comes static versus dynamic. A static AI environment is a scenario in which the data sources are not volatile. That is, they're not changing. Right. So speech analysis systems operate in such environments. All the data is already available and it's not moving around. Right. Dynamic AI environment is exactly the opposite, where the data sources are continuously changing. For example, drones will be dealing with continuously changing data sources, right? In fact, self-driving cars are again an example, but I'll not just repeat the same example again and again. Then there comes discrete versus continuous. A discrete AI environment is a scenario in which a finite set of possibilities can lead to final outcome of the problem. So chess is a very good example. While a continuous AI environment is a scenario in which solutions rely on unknowns and they continuously change, so it's very hard to predict. Again, self-driving cars, very good example for such scenario. Then comes deterministic versus stochastic. Deterministic is where the outcomes can be determined, while stochastic, the outcome in these environments are not based on a specific state. Okay, and there's a lot of uncertainty based on, uh, based on a lot of other factors which are not exactly in control. Self-driving cars once again. Then comes, so that was all about environments. Let's understand neural networks. And honestly, the best way to understand neural networks is by watching this video. It explains in a very lucid way what neural networks are. It's very difficult to explain otherwise. So please have a look. It's a 20-minute long video, but it will give you very good insight on what neural networks are and how much you need to know, understand or know about it. So to conclude, so AI apps, once again, to recap, they deal with agents and environments. So you have to talk about agents, you have to code the agent, and you have to also worry about the environment. So as a product manager, you have to worry about the environment a lot. You have to worry about how much information do you have, how much deterministic or how much discrete or how much competitive or collaborative, what environment is my agent going to work in. And basis that you can take a call or you can advise the developers or you can advise the solution, you can bring out a solution that what kind of agent is required for this particular environment. That's it for now. Thank you.